Probability trees. Question number 1. Tina has 2 bags of counters, bag A and bag B. There are 5 red counters and 3 blue counters in bag A. There are 4 red counters and 5 blue counters in bag B. She takes at random a counter from each bag. Complete the probability tree diagram. Now, total number of counters in bag A are 5 plus 3, which is 8. So probability of getting a red counter from bag A is 5 over 8 because there are 5 red counters and 8 is the total number of counters. And for blue, it's going to be 3 over 8. In bag B, you have 4 plus 5 equals to 9 counters in total. Probability of getting a red counter is 4 over 9 and a blue counter is 5 over 9. Now your probability tree diagram is completed. Let's look at the question. Work out the probability that Tina takes 2 blue counters. Probability of blue and blue. She takes 1 blue counter is 3 over 8. She takes another blue counter is 5 over 9. 3 over 8 times 5 over 9. 5 times 3 is 15. 8 times 9 is 72. 15 over 72. You don't have to simplify this unless stated by the question. Question number 2. Hannah is going to play 1 game of chess and 1 game of backgammon. The probability she will win the game of chess is 0.6. Probability she will not win the match is 1 take away 0.6 to 0.4. The probability she will win the other game is 0.7. And the probability she will not win this game is 0.3. Part B. Work out the probability that Hannah will win both games. She will win and win. .42. Question 3. Rachel has 2 bags. In the first bag, there are 4 red balls and 6 green balls. In the second bag, there are 3 red balls and 5 green balls. Rachel takes at random a ball from the first bag. She then takes at random a ball from the second bag. Complete the probability tree diagram. Total number of balls in the first bag are 10, and in the second bag it's 8. Red is 4, green is 6. Red is 3, green is 5. Part B. Work out the probability that Rachel takes 2 green balls. Green and green. Six times 5 is 30. 10 times 8 is 80. Question number 4. Joe is going to play 1 tennis match and match of squash. The probability she will win the tennis match is 4 over 5. The probability she will win the squash match is 7 over 10. One take away 4 over 5 is 1 over 5. Work out the probability that Joe will win both matches. 7 times 4 is 28. 5 times 10 is 50. Question number 5. Each day, Paul wears either a black tie or a red tie to work. On any day, the probability he wears a black tie is 5/9. Complete the probability tree diagram for Monday and Tuesday. The probability he wears a black tie on any day is 5/9. 1 take away 5/9 is 4/9. Part B. Work out the probability Paul wears different colored ties on Monday and Tuesday. Now here they're saying different colored ties. We will have two different possibilities. Either Paul wears a black tie on Monday and a red tie on Tuesday, or he wears a red tie on Monday and a black tie on Tuesday, because the question is not specifying on which day he's going to wear which tie. So there are two different combinations that you can make. The first is either he wears black tie first and red tie later the other day, or he wears a red tie first and a black tie the other day. Probability of wearing a black tie on Monday is 5/9 times red tie on Tuesday is 4/9. Plus, whenever you have different combinations, you add all of them. Probability of wearing a red tie on Monday is 4/9 times a black tie on Tuesday is 5/9. 5 times 4 is 20. Question number 6. John plays a game where he can win, draw, or lose. The probability John wins any game is 0.5. The probability John draws any game is 0.3. He plays 2 games. Complete the probability tree diagram. Win is 0.5, draw is 0.3, and lose is 0.2. Part B. Work out the probability John wins both games. So win and win. Question number 7. Bradley gets the bus on Saturday and Sunday. The probability that Bradley's bus will be late on any day is 0.2. One take away 0.2 is 0.8. Work out the probability that Bradley's bus is late on at least one of these days. We will have 3 different combinations here. The first combination is that Bradley's bus is late on Saturday and also late on Sunday. Your second combination is it's late on Saturday but not late on Sunday. And your third combination is it's not late on Saturday but late on Sunday. At least, if the question says at least, it means that you could either have one or more than one. So he could be late on one day or more than one day. But if the question says exactly, If instead of at least it says exactly, that means it has to be exactly one. But at least it's not restricting you. It's just saying that you could either have one or more than one. So you could be late on Saturday and on Sunday both, because it says at least. But exactly would mean that he either has to be late on Saturday or on Sunday. He cannot be late on both of those days. Now, probability that he will be late on Saturday is 0.2, and the probability he will be late on Sunday is also 0.2. Probability he will be late on Saturday is 0.2, and not late on Sunday is 0.8. And then it's 0.8 times 0.2. So 0.04 plus 0.16 plus 0.16, which is 0.36. Question number 8. Felicity is going to play one game of chess and one game of draughts. The probability she will win the game of chess is 0.8. The probability she will win the game of draughts is 0.6. Work out the probability that she will win exactly one of these games. The first step here is to draw a probability tree diagram. She will win the game of chess is 0.8. She will lose it is 0.2. She will win this game is 0.6, 0.4. You have to work out the probability that Felicity will win exactly one of these games. Now, the question here says exactly. Exactly means she either has to win chess or draughts. She cannot win both of these games at the same time, because the question is restricting you by saying exactly. If the question instead said at least would mean she could win both of these games at the same time. So with exactly, there will be two combinations. I'll be making them. Probability that she will win the game of chess and lose the game of draughts. Or she loses the game of chess and she wins the game of draughts. These are the only two combinations that you could have. When the question says exactly, she cannot win both the games and she cannot lose both the games. But if the question said at least, then I would include one more possibility, and that would be win and win. She wins both of these games. Now, probability she will win the game of chess is 0.8 times she will lose it is 0.4 plus she will lose the game is 0.2 times she will win the game is 0.6. 0.8 times 0.4 is 0.32 plus 0.6 times 0.2 is 0.12. If you add both of these, it's going to be 0.44. Question number 9. Mimi has two bags. In the first bag, there are 3 red balls and 7 green balls. In the second bag, there are 4 red balls and 5 green balls. Mimi takes at random a ball from the first bag, and then she takes at random a ball from the second bag. Work out the probability that Mimi takes 2 green balls. Your first step is to draw a probability tree diagram. Total number of, okay, you have red, green, red, green, red, and green. Total number of balls in the first bag is 7 plus 3, which is 10. Total number of balls in the second bag are 9. Work out the probability that she takes 2 green balls. Green and green. Seven times 5 is 35. 9 times 10 is 90. Question number 10. Ruler plays a game where she can win, draw, or lose. The probability she wins any game is 0.6. The probability she draws any game is 0.1. She plays 2 games. Work out the probability that she wins exactly one of those games. So she wins any game is 0.6. She draws any game is 0.1. And she loses any game is 0.3. Plus it's 1 take away 0.6 and 0.1, which is 0.3. Work out the probability that she wins exactly one game, which means she can only win one game at one time. She cannot win both the games at the same time. So I will have 2 combinations here. If she wins the first game, she has to lose the second one. If she loses the first game, she has to win the second one. Win is 0.6 times lose is 0.3 plus the probability. She loses the first game is 0.3 times she wins the second game is 0.6. We have more combinations here because there are 3 branches. So she can win the first game and she can draw the second game. She can draw the first game and she can win the second game. Those are the only 4 that will be there. So the probability she wins the first one is 0.6, she draws the second one is 0.1, and she draws the first one is 0.1 times she wins the second one is 0.6. So 0.18 plus 0.18, 0.1 times 0.6 is 0.06 and 0.06. If I add all of them together, it's 0.48. And that was the last question of the spreadsheet.